Okay, so now in this next section, this is chapter 2, section 2, we are just going to start making conjectures and see if we can look for patterns. So this first part of this lesson is just patterning. So what I would like for you to do is pause the video, and then I want you to actually finish this. Draw the 10th object in the pattern. So if you notice, it has the first 7 objects in the pattern drawn for you, and then go ahead and draw what you think is the 8th, the 9th, and the 10th, and you should have some kind of reasoning on why you are actually thinking that that's true. So go ahead and pause the video and work through that. Okay, so we are going to look at what's called inductive reasoning, where basically you just make observations and then you look for a pattern and you make a conjecture. A conjecture is just a statement that's not proven, you just notice it, so that sometimes conjectures can be different for different people. So a conjecture is an unproven statement that's based on observation, and you're using inductive reasoning when you find this pattern and just looking at specific cases, and then you try to write what's going to happen in general based on what you see for a pattern. Okay, so if you notice, okay, let's look at how we would sketch the next figure in the pattern. So we have a circle. Okay, so this first circle is broken in half, the top part is shaded. Okay, so we have 2 pieces. Now they broke it with a second time, and it's the top left that's shaded. And now they broke it with 3 lines into equal pieces, and the top left is shaded. So you have to kind of think about not just how many pieces it's broken into, but which piece is actually shaded. So my conjecture would be that I would draw a circle, and I would draw 4 lines through it, like that. Okay, and I would shade in this piece right here. Use my highlighter. That piece right there, because that's the top left piece. Is that the only conjecture we can make? No, but it's the most logical one. Again, this is just looking at patterns. So if you notice in the stars, okay, it's basically looking at which parts are shaded. Okay, each time something slightly different is shaded, and it's kind of hard to see here. Also, I'll zoom in just a little bit, but you have the middle part shaded darker. Okay, and on this first one you have 1, 2, 3, 4 of the points on the star shaded. Again, you have on the next one you've got the center part shaded darker. Now this time it's got 1 less, so now it only has those 3. Okay, same thing, and then it only has those 2. So if we were looking at a pattern, I would probably say, if we have our star that's drawn here, okay, I would keep my center shaded in, and then which point on the star would I shade in? I would shade in this one based on what I've noticed with my pattern. Okay, and then with the stacking of the circles here, I would probably say that if I'm looking for the next figure, well, we got 1, and then we've got a row with 2, and then we've got a 1, 2, 3. So I would say my next one should probably be 1. Then I got my row of 2, 1, 2, 3. Now I'm just going to add another row, 1, 2, 3, 4. Okay. We talked about what a counterexample is back in the first video of the day. A counterexample is just a specific case for which a conjecture is false. Okay, so it's basically how you can prove it wrong. The counterexample proves it wrong. So I am going to say that the sum of 2 numbers is always greater than the number. Okay, so that's like saying, oh, if I add 2 plus, oops, I wanted to have a pen, 2 plus 2 equals 4. Okay, the sum, which is 4, is always going to be greater than the numbers. Okay, can you think of an example that would make that false? Okay, well, you know, anytime I need to make find a counterexample with numbers, I start thinking, is there positives, negatives, fractions, decimals? Think about the types of numbers that you have. Okay. So, is there a way, can you think of a counterexample when the sum of the 2 numbers is not more than the larger number? I think I might have said that wrong. The sum of 2 numbers is always more than the greater number. So let's think, I think I might have given a bad example. Let's say, whoopsie, 1 plus 2 equals 3. Let's not have the same numbers. So I'm saying that my 3 is always going to be bigger than my larger number here. Okay, so I want you to pause the video and think about if you can come up with a counter example that would make that false. So the example that the counter example, this is my counter example that I came up with, okay, is counter example. Is if I have a negative and a positive. If I have negative 10 plus 3, I get negative 7. Okay, negative 7 is not bigger than 3. Okay, so you can kind of think of different examples. Any counterexample that makes the statement not true. Okay, so here, let's see. Make and test a conjecture about the sign of the product of any 3 negative numbers. Okay, so if I multiply any 3 negative numbers, what would you assume is going to be true? Okay, think about it and see what you can come up with for a conjecture. Okay, so if I was going to conjecture anything from what I know about negative numbers and multiplication, I would say that I believe that if you multiply 3 negative integers, you will get a negative integer. You might have had a different conjecture. That doesn't mean it's incorrect. So could we come up with a counterexample to that? Well, I'm thinking anytime I multiply negative integers, anytime I multiply, 2 of them are going to make a positive, and anytime you multiply a positive times a negative, you always get a negative. So anything that I can think of, I cannot come up with a counterexample, which is fine, which means my statement is true, or my conjecture is true, but maybe your conjecture was something different. So let's see, test a conjecture about the sum of any 5 consecutive integers. Okay, so remember, integers are positive or negative whole numbers, and consecutive means in order, like 1, 2, 3, 4, 5, or 7, 8, 9, 10, or negative 10, negative 9, negative 8, negative 7, negative 6, or something like that. So take a minute, pause the video, and see what you can come up with. So let me think. My conjecture that I'm going to come up with is that if I add up any 5 consecutive integers, the sum will be positive. You might have come up with a different conjecture. Okay, so can I come up with a counterexample where if you add all of the consecutive integers together, it will not be positive? Well, that's not hard to come up with a counterexample, because anytime you have negative numbers like negative 5, negative 4, negative 3, negative 2, negative 1, you're always going to end up with a sum that's negative. So if you use negative integers, would make that a counter example. And the last one, the value of x squared is always greater than the value of x. Okay, so examples, you're thinking 2 squared is 4. 4 is greater than 2. 7 squared is 49. 49 is greater than 7. Can you think of something where when you square it, it actually makes a smaller number? Okay, so again, anytime we're talking about numbers, we want to think positives, negatives, and fractions, decimals, that kind of a thing. So if we're thinking of some counterexamples, I would say one that kids use quite a bit is 1 squared equals 1. Well, 1 squared is 1. It says it's always greater than. Okay, not greater than or equal to, but greater than. So there's an easy counterexample. Or if we think in terms of fractions, if I have 1/2 squared, remember when we square a fraction, we square the top and the bottom, that's 1/4. And 1/4 is not bigger than 1/2. So 1 squared or a fraction squared would be examples of that. And then last one, the sum of the 2 numbers is always greater than their difference. Okay, so the sum of 2 numbers is always greater than their difference. So that's like saying 5 plus 3 equals 8. 5 minus 3. This is the sum, this is the difference. Okay, is there any time where when This would not be true, where this is not greater than that. So again, think positives, negatives, fractions, decimals, all of that kind of stuff. And I'm just going to think, all right, so what if I had some negatives numbers in there? What if I had -5 plus -3 equals -8? Okay, so there's my sum. Okay, my difference would be -5 minus -3, which is -2. That's my difference. Okay, we're saying that the sum is greater than the difference. Well, -8 is not greater than -2, so this would be a counterexample. Okay, and what you're going to have is a short homework assignment in Schoology that is called 2.2 Day 1 homework. It's a short worksheet, so when you're all done, you have 2.2 Day 1 homework. You also had 2.1 Part 1 and Part 2 homework in Schoology, and this is a worksheet and this is a worksheet. So there should be 2 assignments in Schoology, and when you're all finished, you should submit both of them.